So assignment 28, 6.5, the remainder and factor theorems. Your essential question: how do you divide polynomials? And relate the result to the remainder and factor theorems. Okay, so you're going to think I'm crazy right now, but let's just review some stuff. Maybe you learned, I don't know what grade you would learn it in, 3rd or 4th grade maybe, long division. We'll start off easy and then we'll throw some algebra 2 in there. Okay, so what if I wanted to divide 3 into 1,672? Hopefully you all know how to do this. So you'd ask yourself, does 3 go into 1? And it doesn't. So then does 3 go into 16? And it does, right? 5 times. Then I take that 5 and I multiply it by the 3 and I put it down here. And then I subtract. And then I bring down what comes next. And then I repeat the process, right? All right. Here it goes. Now let's do it with polynomials. So we are going to divide 2x to the 4th plus 3x cubed plus 5x minus 1 by x squared minus 2x plus 2. Okay, well, there are a couple ways to do this, but right now I'm going to show you the long division way. Okay, so if we're dividing, like for example, this was 1,672 divided by 3, right? So the number that we're dividing by gets put on the outside, and the number that we are dividing then gets put on the inside. Okay, so same thing with polynomials. So on the outside, I'm going to put this trinomial. And then I'm going to divide that into, what is this, a quadrinomial, 4 terms. All right. So we ask ourselves, and we really just need to look at the first terms, okay? You don't need to look at everything, okay? Oh, however, I've already messed up. What have I done wrong here? And hopefully you know this from synthetic division. What have I done wrong? Well, notice how I go from x to the 4th, x to the 3rd, x to the 1st. So I'm missing a term, correct? So I need to put in a 0 x squared. Then I'll continue with the rest of my terms. Plus 5x minus 1. Okay, so again, I'm going to just look at the first term, okay, the leading term in both of these. And I'm going to ask myself, x squared times what will give me 2x to the 4th? Okay, and that's going to be 2x squared. So there's different ways of doing this. The way that I do it is I start by putting whatever, so I just said I need 2x squared to be able to multiply by x squared to get 2x to the 4th. So I'm going to put my 2x squared over my x squared term. Okay, so I'm going to put it here. Okay, so now instead of just doing the single multiplication, I actually have to take this now and I have to multiply it to every term. So I have to distribute it to everything here. Okay, so I'm going to take 2x squared and I'm going to multiply by x squared and I'm going to get 2x to the fourth, and that goes directly under the term that I'm making it match, right? I'm making that happen, just like we do in long division. Okay, we're doing the best that we can. We want it to match. Here, I couldn't really get it, the whole thing to match. Here, I'm always going to be able to get that first term to match. The rest of it's not going to match. Okay, next term becomes a negative 4x cubed, and the next term becomes a positive 4x squared. So from there, the next thing I would do in my regular long division is I would subtract, which is easy. I'm just subtracting that number. But here I'm subtracting a whole bunch of stuff, right? I'm subtracting this whole thing. So that means now I have to distribute this negative, right? So now the 2x to the fourth becomes negative 2x to the fourth. The 4x cubed becomes positive, and the 4x squared becomes negative. So in order to not look like I haven't taken care of that, now I'm just going to add that, make that a plus, and now I'm going to add these all together. So 2x to the fourth and a negative 2x to the fourth, those are gone, right? And that's my goal. Okay, that has to happen. Anytime that you have your first, whatever your first term is, those have to disappear. This is going to give me 7x cubed, and this is going to give me a negative 4x squared. Okay, so now, here we go again. We're going to start all over again, just like I would here, right? I would say, now 3 goes into 17, how many times? So now I'm asking myself, x squared, oh, you know what? I forgot to bring down, that's the step I forgot. Bring down the positive 5x. Okay, so now ask yourself, x squared goes into 7x cubed how many times? Positive 7x, right? Because that 7x times x squared gives you a 7x cubed. It needs to match exactly, so that way when I do the opposite, right, they cancel out. Then 7x times negative 2x becomes negative 14x squared. Then 7x times positive 2 becomes positive 14x. Okay, again, I subtract the entire quantity here, which means I'm taking the opposite of each of these terms. So that becomes a negative 7x cubed, a positive 14x squared, and a negative 14x. Change that to a positive so I know, hey, now I'm just adding these together. 7x cubed, negative 7x cubed, gone. Again, that's my goal. Those first terms always want to cancel out. Okay, now I add the rest together. So this is going to give me a 10x squared and a negative 9x. And then I bring down the next term. Okay, and then I do the same thing all over again. X squared goes into 10x squared. Oh, positive 10 times. Then I distribute, right? So I get 10x squared. 10 times negative 2x is negative 20x. 10 times 2 becomes positive 20. But I want the opposite of all those. Okay, which means I put the negative out here, so I distribute that. This one becomes negative, this one becomes positive, this one becomes negative. Change that to a plus, add them all together. The x squareds go away. See that pattern there? The first term's always supposed to go away. And this gives me a 11x minus 21. Okay, so let's go back to my long division here that I started with. So if I did this, I would get another 5, 15, 22, so I'd do 7, that would give me 21, and I'd be left with 1, right? So there are different ways we could write it. We could write it remainder 1, like maybe you did in 3rd grade, or we could write it 557 plus 1 over 3, right? Or that's the same thing as 557 and 1/3. Okay? So this is the way where I would like to see it written. Okay? That's going to be the most beneficial for you for when we actually start doing the opposite of this. And the opposite of this would be taking what we divided by, what we got, multiplying them together, and then adding the remainder to it. Okay? So, at the very end here, and because I'm out of room, because I ended up with smaller paper, my quotient is going to be 2x squared plus 7x plus 10 plus 11x minus 21 over what I originally divided by, x squared minus 2x plus 2. Voila, there's your answer. Now, I have a different method for you if you're actually just dividing by a binomial. Okay, here we divided by a trinomial. So if you're dividing by a binomial, we can actually use synthetic division, just like the synthetic substitution that you used, and it's going to be a lot quicker and easier. Okay, so I'm going to flip my paper over. I'm going to introduce to you something called the remainder theorem. So I'm going to give you the formal definition, and then I'll explain it to you. So if a polynomial we'll call our polynomial f of x, is divided by some binomial, and that binomial we're going to call it x minus k, then the remainder is, and your remainder, we'll let that be r, equals f of k, which means you can actually just take this k, plug it in, do synthetic substitution, and your remainder will be that very last, whatever you're left with, okay? So to do this, you're going to use synthetic substitution. Okay, so how do you know what k is? Well, you're always going to take your binomial, for example, x minus k. You'll set that equal to 0, just like you do with any factor, right? And you're going to then add k to both sides, and that's what x is going to be. Okay, so for example, here's an example of this. We are going to divide x cubed plus 2x squared minus 6x minus 9 by x minus 2. Okay, so notice how I'm dividing by a binomial. I mean, if you want to do long division, well, sometimes you can choose sometimes, but other times, I mean, it doesn't make any sense to use long division. It makes a lot of sense to use synthetic division, okay? All right. Oh, and I put synthetic substitution here, which is the same thing as division. Sorry. All right, so the first thing I'm going to do is I'm going to figure out what my k is, okay? What is my k here? So the first thing you do is you just say, well, let me set that equal to 0. So I know that x is going to be 2. So on the outside of my synthetic division, I'm going to have 2. On the inside, I'm going to have the coefficients of each term, making sure that every term has been accounted for, or every degree has been accounted for. So x cubed, x squared, x to the first, x to the 0. So I'm not missing anything, so I don't have to plug any zeros in. Coefficient here is 1, coefficient there is 2, negative 6, negative 9. Okay, so from here I just do the synthetic substitution just like you did before, or synthetic division. Okay, bring down the 1, multiply these two, add them, multiply, add them, multiply, add them. And I get negative 5. This right here, that is my remainder. That's why the remainder theorem is the same thing as using synthetic substitution, because this very last term right here gives you your remainder. Okay? Okay, so one thing I can tell you is that I know, well, f of 2 then has to be negative 5, right? If I were to substitute 2 in here, then I would know that I would get negative 5 out. Or the other thing I would know is that when I divide this quadrinomial by this binomial, what I end up getting is a polynomial, and I'll discuss this in a minute, with some remainder. Okay, so let's talk about this polynomial. So the last term is always your remainder. And so I always start on the right-hand side and work backwards, because it's hard for me to figure out what this is, what degree this is. So looking at this, this is always going to be my linear term. I'm sorry, my constant term, constant. The next one will be my linear. The next one will be my quadratic. And if I had more terms, it would continue from there. If I had another term here, it would be cubic, quartic, and so on. Okay, so if I write this out as a polynomial, it's going to be, well, quadratic means x squared. So I'm going to have 1x squared or x squared. Linear just means x to the first power, so plus 4x. Constant, x to the 0 power, so just 2. And then there's my remainder. So I can say minus 5 over what I originally divided by, which was x minus 2. And there it is. Okay? So from there, we're going to build onto this, and we're going to use something called the factor theorem. This is another way of determining what your factors are. And another way of factoring polynomials. So the factor theorem says that a polynomial we'll call that polynomial f of x still, has a factor so a binomial factor, x minus k, which is usually how we're trying to get our factors, right? We're trying to get them into this x minus k, right? Like when we factor trinomials, we try and get it into binomial factors. Or when we factor a quadrinomial using factoring by grouping, we try to get our factors to be these binomials so we can set them equal to 0, right? So this will be true if and only if f of k equals 0. So basically, when I do my synthetic division here, I will know, like for example here, x minus 2, which is what I divided by originally, will be a factor of this polynomial if the remainder is 0. Here, that's not the case, right? I didn't get a remainder of 0, so x minus 2 is not a factor of this, unfortunately. But what's really cool is if this is a factor of 0, if this is a factor because this equals 0, then what you'll end up with is just another polynomial that you can factor some more, right? Or maybe use quadratic formula on. So our goal with this is to really get down to our quadratics. Once we get down to our quadratics, we can either factor them or use a quadratic formula. Okay, so I might be going a little bit ahead. Let me go ahead and explain to you how to use the factor theorem. Okay, so here's an example. Am I going to run out of room? My paper is really small. I apologize. I'm probably going to run out of room, but that's okay. I'll use another piece of paper. So we have 1, 0 of f of x equals x cubed minus 2x squared minus 9x plus 18 is x minus x equals 2. Find the other zeros. Okay, so hopefully from that exploration that we did on polynomials, I'm talking about in Desmos, like the end behavior, the zeros, the concavity, the points of inflection, the extrema. Hopefully what you got out of that was if the degree of whatever the degree of the polynomial is, the highest degree, that's the maximum number of zeros that that polynomial can have. So if I already know 1 0, how many more zeros could I potentially find? I could potentially in this one find 2 more zeros because there should be, or a maximum of 3 zeros. Okay, so I'm going to use synthetic division. I know that 2 is one of my zeros. Or in other words, I know that x minus 2 is a factor, right? So x minus 2 is a factor, making x equaling to a 0. So I'm going to use synthetic division to divide out this factor from this polynomial. So I'm going to use 1, -2, -9, and 18. Remember, you need to, if we were missing any degrees here, we would have had to put some zeros in there. Now, what should happen according to the factor theorem is that if I am dividing by the actual factor, then my remainder should be 0. Which makes complete sense because if I plug in one of my solutions, somewhere where it's crossing the x-axis, then the value of y where it's crossing the x-axis, or f of k, is going to be 0, right? F of k is the same thing as like the output, the y, okay? And anywhere on the x-axis where I have a solution or a root or 0, right, I'm going to have a 0 for my output, for my y value. Okay, so going back to this. So 2 times 1 is now 2. Add those, I get 0. Multiply, I get 0. That's -9. This is -18. Add those together, I get 0. So you see how my remainder is 0. Okay? So right here, this is important. Okay? This tells me if my remainder is 0, so I'm going to put a little, so remainder equals 0. So I know x minus 2 is a factor. And x minus 2, or x equals 2, is a 0, or a root, or a solution. Okay, so just a little bit more notes on there. Okay, so what I'm left with now, so what this becomes now, let's see, so that was my remainder. I don't need to write anything for that. This is going to be my constant, my linear, my quadratic terms. So now what I'm left with, after I factor out that 2, that x minus 2, okay, what I'm left with is x squared minus 9. Okay, so now it's time for me to factor it some more. Okay, so x squared minus 9 is a difference of 2 squares. You factor that out. Hopefully by now this is second nature for you. Now if you wanted the complete factorization of this, okay, you can't forget about your original factor, right? So your original factor here was x minus 2. So originally, let's see, I'm going to take this and I'm going to just come over here and tell you originally, okay, this would have factored into, actually I'm going to do it right here, where I had already written the x minus 2. it would factor into x minus 2 would be one of my factors, x minus 3 is another, and x plus 3 is another one. So there's the complete factorization of this quadrinomial. And on something like this, actually, we could have used factoring by grouping. That would have been another method that would have been available to us. But sometimes you're not going to have that available to you. Factoring by grouping is not going to happen, and you're going to have to use the factor theorem, okay? All right, so from there, I have to find the rest of my zeros, which means I need to think about this thing being set equal to 0, take each of my factors, set them both equal to 0, and then solve. So my other two roots, or my other two zeros, or my other two x-intercepts, there they are. So if I needed to graph this thing, which you will be doing soon, right, you would know that the end behavior, well, it's odd and it's positive. So I know, and this is just a rough idea, it'd be down on one side, up on the other side. And now I know all my zeros. I know it goes through 2, it goes through 3, and it goes through -3. So let's just have fun with this. Just for fun. You're not actually going to, I don't think you do this in your homework, but I just want to have fun. So I know that 2 is a root, I know that 3 is a root, and I know that -3 is a root. Okay, so that means those are my x-intercepts. I know I'm going to start down here. At some point, I'm going to come up somewhere, turn back around, and do something like this.